The diagram shows a tetrahedron. AD is perpendicular to both AB and AC. So we can see you've been given these right angles. AB is 10 centimetres, AC is 8 centimetres, AD is 5 centimetres. And the angle BAC, this one here, is 90 as well. We need to calculate the size of angle BDC. BDC. So we want to know what this angle here is. I'll call that X. Notice it's 6 marks, so it's quite a long question, but quite simple. We're just going to do the same process over and over again, basically. In order to work out this angle here, I'd like to know, if I was just to draw this triangle out, let me draw it out here. So we've got B, D, C. So I'm just drawing this out flat in 2D to help me. So this is this triangle here, flat in 2D. I want to know this angle. In order to work out this angle, I'd like to know some of these sides. So let's think, how could we work out each of these sides? Well, let's start off with the side CD. Let's start off with this side here. Now, I can see that that is the hypotenuse of this right angle triangle. We've got the triangle ADC, this triangle here, where AD is 5, AC is 8. So I can actually work out DC pretty easily by just doing a bit of Pythagoras. So if I do 5 squared plus 8 squared, I get 89. Then if I'm going to square root that, I'll get root 89 or 9.43 blah 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 blah. I'm actually going to leave it as root 89 for now, because I know this is not my final answer, so I'm going to need to do further calculations with this. So I'd like to leave it in a shorter, simpler form than writing all of these decimals out. So we know that DC, this length here, is root 89. Now let's go to have a look at some of the, if we can find out the length BD or BC. Let's do BD first of all. Let me mark this one on green, BD here. Well, I can see that BD is the hypotenuse of a right angle triangle over here on the far side. So I've got another right angle triangle where I've got BAD. Again, AD, I know that's 5, and BD is 10. So again, if I do a little bit of Pythagoras, I can work out BD. So again, I've got 5 squared plus 10 squared is 125. Square root that, I get 5 root 5, or that. But again, I know I'm not going to use my get a final answer yet, so I'll just leave it as 5 root 5, because that's easier than this whole awkward decimal. So I know that this length over here is 5 root 5. Finally, now I need to work out the length BC. So that's where this other right angle triangle comes in here, because BC is the hypotenuse of this right angle triangle on the bottom. So if I was to draw that right angle triangle out, where I've got A, C, B. So this is this right angle triangle here, ABC, ABC. I know AB is 10. I know AC is 8. So again, let's do a bit of Pythagoras here then. So 10 squared plus 8 squared is 164. Square root that, which is 2 root 41 or 12.806, so on. But again, we'll just leave it as 2 root 41. So we know this side here is 2 root 41. Okay, right, we have now got all 3 sides of this triangle here, so we're now able to work out this angle here. We're going to do this with the cosine rule. Remember, the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Or if you are trying to work out the angle here, you want to rearrange this equation to make cos a the subject. So all of this will go over to the left-hand side to get to 2bc cos a equals b squared plus c squared minus the a squared. So just moving all of that over there, move that over there. Then divide both sides by 2bc. So you get cos a equals b squared plus c squared minus a squared all over 2bc. I know some people just prefer to remember this formula, which is fine for your GCSE, but it's pretty easy just to remember how to rearrange it from here. Anyway, we can now use this formula to work out this. We just need to remember and decide what B, C and A are going to be. B and C, it doesn't matter. You can do those either way round, but the important thing is A has to be the side that is opposite the angle you want to work out. So A has to be 2 root 41. The other ones here don't really matter. That can be B, that can be C, that can be C, that can be B. It doesn't matter, but that has to be A. So I will do cos A equals, I'll call this one B and I'll call that one C. And obviously, like I said, that one's A. So I've got root 89 all squared plus 5 root 5 all squared minus 2 root 41 all squared, all divided by 2 times root 89 times 5 root 5. So I've not set this out very well. This is my b squared plus c squared minus a squared, all divided by 2 times root 89 times 5 root 5. So I'll use my calculator to do this. So I've got root 89, put my bracket in the wrong place, root 89 all squared plus 5 root 5 all squared minus 2 root 41 all squared, all divided by 2 times root 89 times 5 root 5, which gives that. So that's what cos A equals. I obviously want to know the inverse. I'm going to do the cos inverse of all of that now. So I do cos inverse, so shift cos answer. I get the angle to 1 decimal place as being 76.3 degrees. So there we go. Apologies for this being a bit crammed down here, but hopefully it's clear the method of how to do that. It's all about breaking this 3D shape down into simpler 2D shapes in a series of simple stages so that you can then use the cosine rule.